Hello and welcome to this course, ASP.NET Core Cloud Native App Development. I'm your instructor, Trevoir Williams, and I have been a software engineer and lecturer for the past decade. Now, this course, it's going to be simple, but not really. We're going to be looking at building a cloud native application. So this means we're going to look at containerization. We're going to explore what the concepts of images and containers really mean. Along the way, we're going to learn Docker. We're going to learn both how to use the user interface and the command line. We'll understand how Docker files work, look at how we can publish our own Docker images, explore orchestration using Docker Compose and Kubernetes, which means we're going to look at how we can author K8 manifests or Kubernetes configuration files. And then ultimately, we'll look at .NET Aspire, which is a brand new .NET technology geared towards helping us to build cloud native applications, but it is in preview at the time of this recording. In terms of learning development tools and libraries, we will be using .NET 8 for the majority of the course, but do know that the majority of the concepts that we will look into are compatible with at least .NET 6 and upwards. We'll also be using Visual Studio 2022 for the majority of the course. However, for very critical things, I will show how the equivalent operations can be handled in the Visual Studio Code environment. We'll look at how to use Nginx as a reverse proxy, and along the way, we'll take a deep dive into how Docker works, how we can use it to containerize our applications, and how we can use Kubernetes to orchestrate those applications. Now, before we get into the meat of the matter, I just want to take a quick architectural overview of what we're hoping to accomplish between when we start this course and when we finish. So, a quick overview of the project. We're going to focus more on architecture than coding. If you need to learn coding or you're not so comfortable, I have several other courses that you can check out that will bring you from scratch to at least an intermediate/advanced level in development. So this is not the course for you to learn how to develop a program. This is the course where you're going to come because you know how to develop a program, but you need to understand modern architectural standards and styles. So we're going to focus on implementation using .NET technology, and whatever concepts you're learning from that infrastructure and architectural perspective are applicable concepts to other development stacks. So once again, we're just looking mostly at practical implementation and infrastructure design and how we can design a cloud native application or a portable application that can be deployed on several platforms and still work. And we're using modern technology, standards, and techniques. So the first level of our exploration will see us containerizing a database. We're going to be using SQL Server, but we're going to look at how we can put a database in a container and why we would probably want to do that. Then we're going to containerize an API, which is then going to connect to the containerized database. So now we have two components that are in their individual containers but able to communicate. Once you have installed it, what you will get is access to the Docker command line commands. So once you have it installed, hit pause, let it install, and then you can continue. I would encourage you to launch your terminal. So once again, I'm using a Windows machine, but your terminal on Linux or Mac OS X would look very similar to this. And you can simply run the command Docker just to make sure that it's installed. And if you see something looking like this, then you know you have access to the Docker CLI commands. All right. So what we want to do at this point is run a command that's called Docker pull. Let me zoom in a bit so it's easier to read. So we're going to do Docker pull. So Docker pull, and then we're going to pull this, what we call image. So Docker has predefined files that outline the environment that is needed for a particular application, and these are called images. So the image that we want is the Microsoft MS SQL Server image. So we're going to do a Docker pull against that image. So you can hit pause, make sure you type it in just the way I have it. And when you press enter, it is going to go ahead say, okay, I'm getting latest, and then you're going to see it downloading. So I already pulled that image, so I already have it on my machine, but you're going to see it say pulling, and then it's going to start showing you metrics of it downloading, and it would actually look something more like this. So this is a screenshot I took earlier from when I was downloading it, and you're going to see that it's going to spawn up a bunch of lines looking similar to this, and you're going to have these downloading tags. So once that is completed, the next step is to actually run it. So to run it, you need this command. So we're going to say docker run, and then -e, and then we'll do the EULA accept. So what happens is that SQL Server usually has one of those documents that you need to accept the terms and conditions to. So we're just putting it in the parameter that yes, we accept the terms and conditions. And then another one that says SA password. So if you looked at the installation process when we're using Windows, we can use Windows authentication to connect to the database, right? So all we need is a machine name, and we can use the Windows user, the current Windows user, Windows authentication, and just connect. Now, because this is Docker and it's a container, there's no Windows or there's no Mac or there's no Linux authentication. So it's not really that you can just connect using the default user on your computer. So this step is applicable whether you're using Windows, Mac, Linux, etc. So what we need to do is specify an SA password. So SA is the default user, which means system admin or system administrator. Every time you install a database engine for Microsoft SQL Server, you get this SA user. So we're going to set up this SA password, and you can put in any password you wish, right? I'm just putting in a strong password here. And this is really a password that you might see in other demos that you might watch anywhere on the internet. So this password is not necessarily unique to me or to this exercise. You can put in any password value that you feel comfortable with and you know you will remember. So I'm just putting the word strong password, of course, with special characters, numerals, and a couple capital letters. Then we specify the port. So the port here at the front is the port that we want to go through, and the port on the other end of the colon is the port that it will map to. So what this means is SQL Server by default broadcasts from port 1433. That's the default port. So without doing anything, specifying any port or anything, we'll always go through 1433 once we're connecting. However, Docker is running in its own specialized environment. So we need to map. So this is the default port, and then this is the port from our machine that we want to tunnel through to get to this port. So you could actually just leave that as 1433, 1433. So if you don't have SQL Server installed already and you're running Mac and Linux, then 1433, 1433 is fine. You don't have to do anything extra. You can just connect. However, because I'm using a Windows machine, I had to change my port because 1433 is already occupied by my native SQL Server installation. So I'm just showing you that you can do 1433, 1433 by default, or you can put in your own specific port if you so desire. Then the next and final thing is we say -d, and then we specify the image that we want to run. So basically we're saying, Docker, run this image and make sure that all of these parameters in between are configured. That's essentially what we just did. So when you press enter and you allow this one to run, what it will do is launch that image inside of the Docker UI. So in the Docker UI, you're going to see something looking like this. It's going to appear under containers, and you can see here that I have several containers, right? I even have another SQL container that I'd installed from earlier, and here's the new one from my just running that command. So it created a brand new container for Microsoft SQL Server, and it is currently running, and it's been running for 30 seconds. And the port it uses is 1400, which if you didn't change that and you use the default 1433, would be 1433. You can always stop and start the containers. You can also delete, and you can also watch what is happening. So you can open it in the terminal, and you can interact with it here. You can also inspect to see the health of it and look at some of the configurations, right? So these are some of the environment variables that we had set up, or the parameters that we passed in. You can also look at the logs. So you see here that it seems to have started up successfully. So after I've confirmed all of these things, now I would want to connect. Now, for Windows, we can use the Microsoft SQL Server Management Studio. However, Management Studio is not necessarily available on Linux and Mac. So the alternative here would be to get the Azure Data Studio. You can simply do a Google search and you can go ahead and follow the Microsoft documentation to the Azure Data Studio. However, to connect, let me just show you how we connect to. So you can see I've connected to quite a few apps over the time, or databases rather. But here I'm going to connect Microsoft SQL Server, and then the server here is going to be localhost, comma, the port that you specified. So in my case, I specified 1400 on my port. You might have specified 1400 as well, or whatever it is that you specified when we said the container should run. And if you don't remember, you can just go back over and look. So you specify that port, and then not Windows authentication, but SQL login. And our username is SA, and our password is the password that we typed. And once again, if you don't remember what that password is, you can always go to the container and then click inspect. And I can just copy this value and then paste it. And then for future, you just remember password. Then we can connect. And then this is a sign of a successful connection. And you'll see here that OS version. So I am still on my Windows machine, but the OS version that it has detected is Ubuntu. So that is what the container is doing. It is running in a Linux environment, but it's simulating the environment, the exact environment needed for SQL Server to be able to run. So if I expand databases, you'll see it's empty, and then basically everything that we can do from the Management Studio, we can do from here. One thing that you may notice though is that some of the tooling is limited. So in the Management Studio, I can easily or more easily right click and say do certain things like create a new database and so on. In the Data Studio, however, it will probably have to be scripted. So it's something that you'd have to Control N, create a new script file, and then to create a new database, you'd have to say create database, and then state the name, let's say test DB, and then F5, and then it gets run. So then you can refresh the list of databases and then you'll see test DB, right? But in this course, we're going to be looking at how to do both scripts and use the graphical user interface in the Management Studio. So you should be able to follow along quite fine. And at any rate, if you run into difficulties, feel free to reach out. So now let us create our project. So I'm using Visual Studio first, and then I'm going to show you how you can use Visual Studio Code to replicate these steps. So the first thing I want to do is create a new solution. So once you get to that create new project screen, you can just search here in the templates for a blank solution. I already have it on the side, so I'll just select it. And then we're calling this application Conference Attendees. All right. Nice and simple application, just so we can get through the main concepts. Then we're going to create that solution. And then inside of that solution, I'm going to go ahead and add a new project again. And this time we want an API. So you can search for the .NET Core Web API. So once you select that, we're calling this one, once again, Conference Attendees .API. And then we can confirm the version of .NET. In this course, we're using .NET 8. However, it is what the techniques that we're going to be going through are largely supported by .NET 6, definitely supported by .NET 7, and will be supported by .NET 9. So you can go ahead and select that. Now, during this creation process, you're going to see that there is the option to enable Docker. So you can easily enable Docker at this point. However, I will hold off because I want to show you how you can add Docker support after the fact. And whatever this option would do is what we're going to do when we add Docker support. So it's better to see how to add Docker support manually so that you can retrofit existing applications using that technique. Since it is an API, I'll just opt to use controllers just to keep it simple. But if you want, you can do minimal API and untick that. But I suggest you just follow along so that we can be on the same page, and then we can go ahead and hit create. All right, so since creating the project, I made a few changes, and you can follow along and replicate them if you wish, but of course you can always make reference to the code in the GitHub link provided. So the first thing that I did was to create a folder called data, and in data I have a folder called configurations, and I have several files. So this will form the basis for the database that we're going to be using to support our application. So the first file I want to bring to your attention is the application DB context. Now, we're using Entity Framework Core. So that means we're inheriting from the DB context class. And of course, I need to add a using statement for Microsoft.Entity Framework Core. And more specifically, I am using the following packages: Entity Framework Core, Tools, Design, and SQL Server. All right, don't have to worry about the other packages. For now, just focus on the Entity Framework Core, core.tools, Design, and SQL Server. So with those there, I can now create a class and inherit the DB context. Of course, we have our constructor that is passing down the options that are being passed in through the dependency injection down to the base. And if you're familiar with setting up a .NET Core project with EF Core, then I'm sure you're familiar with all of what I'm explaining right now. In the on-model creating, I'm simply applying all of the configurations that are in the assembly. And we have 4 tables here. So we have attendees, genders, job roles, and referral sources. And each one has a corresponding data model. So I'm going to start off with the base entity. The base entity is simply using a GUID ID key, and it is an abstract class, and every entity is going to inherit from our base entity. So referral source inherits from base entity, and it introduces name. And job role and gender are basically identical. So same inheritance, same property, same inheritance, same property for gender. Attendee, however, has a few more properties. Yes, we're still inheriting from base entity, but we have first name, last name, email address, phone number, and company name. We also have provisions for foreign keys to the referral source, the job role, and the gender. Then we have some configurations for seeding. So the first one is gender. We're seeding in 2 genders, 1 male, 1 female. We're seeding in a few job roles, so manager, supervisor, etc. And finally, we're seeding in the referral source, and we have a few internet advertisement, television, etc. So you can, of course, create your own values if you want to. That's kind of secondary. I just kind of did this so that we can have all of this bootstrapped for our project, so we can focus less on coding and more on the architectural and infrastructural side of what we're doing. Now in our program.cs, we want to configure our application to actually know about the database context and know where to find the database itself. So we're saying builder.services at db context, and we're passing in the application db context class. And I'm passing in the option here where we can say use SQL Server, and we've just passed in builder.configuration.get connection string and the connection string name. So essentially what happens here is that we are telling our app we want to use SQL Server. That is possible because we have the efcore.sql server package, and we are specifying that we want this connection string, which is the value that I have in my app settings.json. So in your app settings.json, you can create this new section named connection strings, and in there, give it an appropriate name. So that's the name I use, or the key, and that is the key that you'll use as a reference in this section. Now, my connection string quickly is pointing to a server called localhost, 1400. Now remember, when we set up our SQL Server, that is the port that I chose to be my SQL Server in the Docker container. So whether you're coding this on Visual Studio and Mac or on Linux or whatever, we're going to be using that Docker container as our database container from the get-go. All right. So server is equal to the localhost, 1400, or whatever port you told your Docker that you want your SQL Server to be hosted at. We have the database name. Trusted connection is equal to false. Multiple active result sets is equal to true. Encrypt is equal to false. And I'm passing the username and the password that I set up my database server to use. All right. So once again, you can always reference the code in GitHub. So since we set up all of the configurations and tables, the next thing that we want to do is add a migration. So if you're not familiar with the process of adding a migration, all you have to do is, if you're using Visual Studio, you can use the Package Manager console, and you get to that by going to Tools, and you get Package Manager and the Package Manager console. And once that launches, you can do add-migration and then say something like initial migration. I would suggest that you don't put a space in the migration name, but using this command will generate a migration file for you. All right, so now what we want to do is connect the application code to our container hosted database server. So the first thing that you want to do is make sure the server is available and can be connected to, because obviously if we cannot connect to the server, then it doesn't make sense to try to update the database. We get an error. So I'm going to launch my Azure Data Studio, and what I'm going to do is start up a new server connection. And here you can actually choose to connect with parameters where you put in the server, put in database, etc., etc., or you can just use the connection string. So I think that's easier because you know the connection string. So you can just copy the part between the quotation marks. Don't get the quotation marks, it will give you an error. And you can just paste that here and then click connect. All right, and then after a few seconds, I get this error: network related or instance specific error has occurred. So if you have spent enough time around SQL Server, you can definitely tell that this is just saying it could not make a connection because it cannot see the server. Now, why can't it see the server? Well, in my case, it's an easy answer. It's because I don't have the container running. So that's another convenient thing about containers. If you don't want the app running, you stop the container. When you want it, you start it back. All right, so since the last time you saw my Docker UI, I did some cleaning up and some refactoring. But here is my SQL container, and you see that it is in a stopped state. So I'm just going to go ahead and start it. I can do that by clicking start here. I can click on the container and click start there. And alternatively, if you have the CLI or prefer to use the CLI, you can always do something like docker ps-a. First of all, to see all of the containers that you have running. And well, you'll see here, this is the name. It looks kind of distorted because I need to zoom out. So here you can see the name. So once you have the name, then the easy command here to do is docker start and then the name of the container that you wish to start. So docker start SQL1. Either method works. You use the one that you're more comfortable with. But the bottom line is that the SQL Server is now running and it should be accessible from my data studio. So let us try to connect once again. All right, so we're getting a different error, still an error, but a different error because it's saying cannot open the database conference attendee DB. The database does not exist on the server as yet. As per the connection string, we're actually targeting that database. So at least now we know that there's communication with the server, but the database doesn't exist. So that's fine. Let us jump back over to our Visual Studio. And what we're going to do is in the Package Manager console, we're going to run a command that says update database. And always make sure that you spell check. Let's try that again. So update database is going to start a build, and once that is successful, it will start executing the scripts that will carry out the migration against the database. So you can just give it a little time, but once it is done, you'll see the message that says done. As long as you don't see any red, you're good to go. So here you see I got an error because of my spelling error. I did odd pate. All right. So now the database seems to have been created, or at least according to the migration, it was created. The update database command will look at the connection string, make sure it can communicate, and then attempt the creation. So if I relaunch the Data Studio and retry this connection string, then voila, now we are in. And you'll notice that we have all the tables that we just discussed. If I expand tables, you'll see them. And run a select query against any one of them, then you'll see the data that was seeded. So at this point, what we have is our .NET Core application or API talking to our database on our container. And this is great because now it doesn't matter what platform you're on, and it doesn't matter what limitations may obtain for SQL Server relative to that platform. You can easily spin up one or more SQL Server based containers or containers based on the SQL Server image, and even specific versions of SQL Server, because this image would have given us the latest, which is 2022. But what if you needed to work with 2018, right? So you can always go and get the specific version, get the specific image, and create a specific container for your needs. So the final thing that I want to show you relative to code that is in the project is the fact that I would have gone ahead and added some controllers. So already kind of scaffolded out controllers for attendees, genders, job roles, and referral sources. And if you're not so familiar with how that is done, you can easily right click controllers, add, and you just add a new controller. Then you're going to choose the API controller, and you're going to say API controller with actions using entity framework. Click add. Then this dialog box will come up to confirm which model class it is that you want to create the controller based on. So if you're doing the controller for attendees, then you would do the attendee model. The DB context class, we only have one, but in a situation where you have multiple, you choose the appropriate one. And then you write in the controller name. Usually the default generated name is good enough. Here you'll see there's a numeral 1 here because I already have an attendees controller. But once you click add, it will take a while, install additional packages for code generation. And then when it's done with all of that, it will generate your controllers. Now, if you get any errors during that generation process, it is likely that maybe you have some version mismatches between your EF Core packages. So always just double check and make sure that you're always on the latest available, latest stable version, or at least all of them are on the same version, even if not the latest. And then you can try again. So now when we come back, we can test out our API and just test and make sure that we actually will be storing stuff in the database that is now on the container. All right, so now we're going to discuss the concept of a Dockerfile. So a Dockerfile is a file that contains instructions on how to build an image or how the image for the application should be constructed. Essentially, it automates the creation of an image and the container for an application. This ensures consistency in creating an image for a container on any system. It simplifies deployment and the application isolation. So now we're going to jump over to Visual Studio and we're going to look at how we add one in Visual Studio, and then we'll look at how we add one in Visual Studio Code. All right, so now we're in Visual Studio and we want to start from scratch and add a Dockerfile. Now remember that when we were creating our project, we actually had the option to add Docker support. I didn't choose that item because I want to show you that it is possible to add Docker support at any time during the development proceedings. So had you chosen the option, then you would have gotten a Dockerfile. Since we didn't, we have to create one, and that is very easy to do. Simply select the project, and in this case, we're using our API project that we already have created and have been working with. Right click it, and then you're going to go down and you'll see add, and we're going to choose Docker support. Now, when you click that, you'll get an option. They're going to ask you, do you want to target Linux or Windows? I'll leave it on Linux. And they want to ask if you want the .NET SDK build type or the Docker file. Let's choose the Docker file and click OK. And in no time, we have this text document that contains several instructions outlining how our Docker image and the resulting container should be constructed based on the application that we're using. So very quickly, I'm just going to walk you through the sections. I'm not going to walk you line by line to explain every single thing that's happening, but it's good to have a general idea of what this file is doing. So the first thing it's doing is pulling down a base image. So what you do regarding a base image is the application we're building is built on .NET 8, which means that they are supporting libraries that would be needed even if we run it on Windows, which is why we install the SDK and the runtime. In this case, for the application to be compiled and actually run, we need a base image that has basic instructions on how a .NET Core application should run in the container. So that is what this line means. Then it goes on to say, okay, we're using something called app. We're calling it app, and we're working with a directory called app. And you'll see expose here. That's optional, but since .NET 8, 8080 and 8081 are the default ports for HTTP and HTTPS traffic. In previous versions of a Dockerfile, you might not see those two. All right. So it has to be explicit that when running in the container, target those ports as the HTTP and HTTPS ports for a .NET Core application. Now, this section of the Dockerfile essentially sets up that we are building in release. We want to set the working directory to be source. We're copying over all of the source code project files into that area. We're running a .NET restore, so we're restoring all the NuGet packages, and then we're doing a build. After we have built, then we publish. And then after we have published, we're going to move from the publish folder to the working directory for the application. And then we set the entry point, because whenever we run a .NET app, we're actually running against that DLL. So whatever DLL gets generated with the same name as the project, that is usually the entry point. So we're telling the container, when you run, here is where you find the executable to run against. So that is what a Dockerfile entails. Now, a Dockerfile in Visual Studio Code, it's going to produce roughly the same file. It's just that the steps are a bit different. So what you want to do is up top, you're going to click there where you would click to search or go to a file. And then you'll see here, show or run commands. So whether you use a keyboard shortcut or you use that greater than sign or you just click it, you'll then be able to type Docker. And you'll see there the option Docker add Docker files to workspace. So if I click that and then select the platform, so just to show you that it is not necessarily unique to .NET Core, most of the frameworks and apps that result from building an app in a framework can be containerized. In this case, we're using ASP.NET Core. So I'm going to choose the ASP.NET Core option, and I'll retain the Linux option. Then they say, what port does your app want to listen on? So remember that when we're setting up our container for our SQL Server, we could have chosen the port. Here they're suggesting a port. I'll just leave that as the default since I have no competing ports on my machine. And they ask about Docker Compose. We're not quite ready for Docker Compose, so I'm going to say no. And then give it a few, and you'll see that I already had it, but don't worry about that. You can always click away any prompts and then you get your resulting file. Now this file basically has the same set of instructions that we just looked at. The only major difference here is that it's talking about the environment variable, and that environment variable is ASP.NET Core underscore URLs, and you'll see here that it gives a default URL. Now this env represents the environment variable. So I'm going to jump back over to Visual Studio and we're going to discuss environment variables a little bit. And I'm going to show you some differences that introducing the Dockerfile will bring about. Now, environment variables are essential for making sure that your application runs the way you want it to. The thing is, if you're not aware of them, then you'll be oblivious to them and you won't notice how powerful and influential they really are. So the file I have open here is the launch settings.json inside of the API project. Now, you generally don't ever need to modify launch settings, and if you do, it's usually because you have a very specific need and you know exactly what you're doing. However, what I want to point out is that when the app was created, we were able to run it as HTTP, HTTPS, or as IIS Express. When we tested it, HTTPS was the option there. Well, these options here actually come from profiles that are inside of the launch settings.json. And each profile outlines maybe different parameters that are needed for it to run under that profile. So HTTP would run on the application URL and port 5178, whereas HTTPS can run on 5178 and 7106. So when we run as HTTPS, it uses this profile where it has a command, it launches the browser, it's true, it launches to Swagger, and then this section outlines the ASP.NET Core environment. So this is an environment variable. And you see that each profile has a section for environment variables. Actually, your whole machine, your OS, has a whole section for environment variables. So whenever we're running inside of Visual Studio, we're automatically going to be running on the development profile, because the launch profile here has the ASP.NET Core environment for development. And then what you probably do not realize is when you publish and deploy your ASP.NET Core application, you're actually running with the environment variable of production. So if it cannot see this environment variable in the environment it's running in, like on your machine, you probably don't have this by default, or on the server you deploy it, you don't have that environment variable by default. So unless you explicitly state otherwise, then it's going to assume it's production. So that is why here it's explicitly stating that we're running as development. All right. So that's just a little introduction as to what is really happening in this launch settings.json file. Now you would notice that you have another profile here called container Dockerfile. So once you introduce the Dockerfile, you now have the option to run under containers. So if you scroll down a little bit, or maybe you didn't have to scroll based on your text size and screen size, but here you'll see the new profile, container Dockerfile. This command name says Docker, unlike the other one that says IIS Express or just says project. All right. We also have launch browser is true. We have the launch URL being set by other environment variables that are being served up. And then here you'll see the environment variables are set to ASP.NET Core HTTPS ports 8081 and HTTP 8080. So those are the environment variables courtesy of ASP.NET Core. For when it's running in the container, it's going to use these as the default ports instead of 80 and 443 traditionally. Then it says publish all ports true and use SSL is also true. So that is what is really happening inside of that profile for the containers. Now, when we come back, we're going to launch and then we're going to take our time and see some of the different things that are happening in our system once we launch our ASP.NET Core application as a container. Now, when we want to run our container or our app as a container, we have to make sure that we have Docker Desktop running. And once we can confirm that the engine is running, just the same way that we had to make sure that we had the Docker Desktop and by extension the container for SQL Server running, just make sure that you have the engine running for your Docker installation. Now, once you go back to Visual Studio or Visual Studio Code, what you want to do is run. So I'm going to run with debugging and allow Visual Studio to read the Docker file, construct the image, and then construct the container needed to run our application. So you can give it a few. It may take a while on the very first run. And Houston, we have a problem. All right, so I encountered this error, and if you are using my source code, you probably will. And if you don't, that's fine, but I'm going to explain it. You know, I don't shy away from errors. So inside of the program.cs, I had added a section where I would force the migration of the DB context at any time. So anytime the app starts up, it should try to just migrate the database, run the migrations, and start the application accordingly. Now, what is happening is I don't have my SQL Server container running. So this is a problem that we're going to look at more closely and solve in a more automated way later on in the course. But I am bringing you present to the fact that because we're trying to connect to a container-based database, if the container isn't running and the app tries to start up and connect to it, then obviously we'll fall into an error. What I'm going to do for now, however, is comment this out. It's not absolutely needed because I actually already have the database, and then I'm going to try and run again. Now, if you encounter the error, that's fine. You just do what I did, and run again. But what you'll notice is that the second time, it's going to load much more quickly. Now, why is that happening? Well, first of all, we get our Swagger document here, and you'll see here the port is running as 32776. All right, that looks good. Now, you'll also notice in Visual Studio, you have a new section or new panel that's called Containers. And in this Containers panel, you have to the left a list of containers that Visual Studio knows and cares about. So I actually have two containers running in my system. I have this new container designed for the app, and I have another container, which is the SQL Server container. And it's very convenient because I can actually start the container right here. And by clicking the container, I can actually see that the environment variables that were used, labels, the ports, all of those things, volumes, etc. So for our newly constructed API container, I can see here that the ASP.NET Core environment variable is development. It has the ports for HTTP and HTTPS implied, several things. Once again, you don't really have to know each of these in detail, at least not right now. We look at the labels. I didn't specify any label for this container, so the label is default. You'll always get the latest. The ports are here, so you see that 8080 is mapping to 32777 and 8081 is mapping to 32776, which is why our browser running in HTTPS is bringing up 32776. So that is the internal port that the container is using to forward HTTPS traffic. And then you'll see volumes and files and details. So files is actually a convenient tab because you can actually see the file system of the container, and here are the published files from the published activity in the app folder. All right. Now, all of this is visible in Visual Studio, but the thing is, if you jump over to your Docker desktop and go to, let's start with images, you see that you have a new image. So you have a new image called whatever it is your app is called. The tag here is dev. So that's a default tag. And you can actually use this to start or run a container. Now it's already running because obviously it was constructed for us by Visual Studio alongside the image. So here is the running container that we're just looking at in Visual Studio. And by now, if you click it, you're going to see the log stream. You can inspect and look at the different environment variables, etc. So you can interact with your container that is hosting your app just the same way that you would with any other container. Now in Visual Studio Code, if you want to run your Docker container or run your project in the Docker container, what you do is go down to the Run and Debug tab, and then you can choose Docker.NET Launch here. Now I already clicked it, which is why you see so many things happening already in the background. And you'll see here, it's attempting to launch the API, and then it should go to /swagger. And there we go. So this Docker container is running at 32778 for our Visual Studio Code project. Now, obviously, I'm not keeping this up as I am with the other one. This is for demo purposes, but I'm just showing you how, whether you're in Visual Studio or Visual Studio Code, how we can accomplish the same things. And just the same way, if I jump over to Docker Desktop, I'm going to see that I now have another image. So the image, I have Conference Attendees API, which is the Visual Studio project. And then Conference Attendees, that's another image, which is the Visual Studio Code project. And then, of course, we have a new container for the Conference Attendees -dev, which is the Visual Studio Code project that is mapping 32778 to 5268. All right. So once again, just giving you some insight as to how, whether you're using Visual Studio or Visual Studio Code, you can accomplish the same things. Now, finally, I'm going to run a quick test where I'm going to just show you that we're in debug mode. And that means even though we're running as a container, we can still carry out our debugging activities as we need to. So let us say I wanted to set a breakpoint on the get attendees endpoint for the project. So if I jump back over to Swagger and I say get attendees and execute that method, then you'll see here it hits the breakpoint just the same way. And then if I continue, and it should give an error because we don't have a database, of course, then we get our 500 error in Swagger. But notice that we're also seeing that log stream right here in the debug panel, letting us know what the errors are. And of course, this would replace that terminal window that usually comes up when you are running the ASP.NET Core application directly. You would also be able to see all of that information inside of the log stream inside of Docker Desktop. So I'm just showing you that even though we have containerized our app, we still have access to a lot of the insight that we would want to see when we're debugging our application. So in our previous lesson, we looked at how we can use the .NET publish command to generate a container. And of course, it went out as a production ready container, and with release configurations, those are parameters that can be changed. But the big issue was that it could not connect to the database. So while the API was running and the container was running, the API was ready. Every time we tried to access some data that required the database, it failed. Now, this is because Docker has its own internal network. So when you say localhost, come off 1400 and run from Visual Studio is kind of inferencing or making inferences as to what localhost is, etc. However, when the container is put out by itself and it's basically out there in the registry, it's not going to see localhost the same way. So we have to now rely on the Docker internal network to make sure that our things still connect. So to do that, we can replace the local host here with host.docker.internal, and we still have the comma, that's host with an S, host.docker.internal. Let me get my spelling right. There we go. And we still retain the comma and the port. So obviously, you put in the appropriate port for the database. We have established that. But instead of saying localhost, you now say host.docker.internal. Now, what this will do is say, look on the internal network and broadcast or connect to whatever app is broadcasting from that particular port. So first, I'm going to test internally. So I'm just going to I'll run without debugging just to launch the Swagger UI window, and then we can do a quick test running from Visual Studio in development mode just to ensure that that connection to the database still works. So we have our Swagger doc, and I'm just going to do a quick get operation on the genders endpoint. And here we have a 200 success response. So that's good. Now, let us try again with our .NET publish. So the first thing you have to do is make sure that you do a .NET publish. I'm just pressing up until I get back the command. The reason we have to go up and do the .NET publish again is so that we can recreate the image. Remember that an image is immutable. So that means that it's not going to assume that because you changed the source code, the image has changed, because the image is a snapshot of what existed when the app was when the app was published. All right. So we want to do a .NET publish with the container again. It's going to do the MS build. It's going to check the local registry if a container by that name already exists, and if not, it will go ahead and create a new one. And if it does, then it will overwrite it. So it will replace the latest. So we talked about tags with latest. So it will just create a new latest, and it pushed that image to the registry. All right. So now that we have that, I'm going to do the Docker run, and let's start that up. Now that is running, and if I jump over to Postman and try the same endpoint, now we have success. So that is basically what you have to do when you are working with other containers. You can't just connect to localhost as if you're connecting directly to the service as it would have been installed on your machine. And once again, the reason for this is portability, right? Because the container should be able to move from system to system. So Docker, as the container hosting platform or application, is creating its own internal networking so that you don't have to rely on the underlying infrastructure or the machine that Docker is installed on.